We will wait 1 or 2 minutes more so that other participants will also be joining. Our expert has already been joined, so we'll take 1 or 2 minutes more. Okay, welcome back. Welcome back, all the participants. So now we will start the lab sessions. So we have our expert with us, Dr. Aditi Bajaj. Dr. Aditi, can you hear us? Can you unmute yourself?
Yes, sir. Am I audible now?
Yes. Yeah, please.
Okay.
So
Good
I'm
afternoon, sir.
introducing Dr. Aditi. Dr. Aditi Bajaj is a project scientist at CSIR-CSIO, where she is working on ICMR funded research project in partnership with Department of Cardiology at PGI Chandigarh. She holds a PhD and her expertise lies in leveraging AI, ML, and deep learning to analyze complex biomedical signals and images, enabling data-driven insights for clinical research. So with this introduction, I invite Dr. Aditi Bajaj for taking the lab sessions. She will be taking both the sessions today and tomorrow, both the sessions. So 4 sessions she will be taking. So I request all the participants to cooperate with her. And if you have any doubt or anything, you can prompt her to solve those issues. And she will start the lab session from basic or from starting. So please cooperate with her. Thank you. So I invite Dr. Aditi over to you.
Thank you so much, sir. Good afternoon, everyone. I'll be sharing my screen and then we quickly start the session for today. Just a second, sir. I'm sharing it once again.
Yeah, please take your time.
Okay. So this is our second workshop of artificial intelligence and computational imaging in healthcare. So this, for as Sir has already mentioned, that I will be taking your next two sessions today and tomorrow. So this is the practical session on medical image analysis with artificial intelligence. In this session, we will cover the Python programming, the essential concepts of the Python programming which are required for analyzing the image, and then moving on to the image processing concepts. And then finally, on day two, we will cover the machine learning and the deep learning aspects of image classification, which is required in healthcare. So this is the foundation of our today's uh, session. First of all, we will start with the Python setup for seamless performance of the tools which or for the lecture which I am going to demonstrate. I'll prefer today the Colab because it's easy to use and we don't need much of an installation. So we will quickly go on to the setup with the Colab, and then we will move on to the Python essentials, in which we will learn about the data types, operations, and the other fundamental programming concepts which are required for the computing of image analysis. And then we will start with the image processing part. And on day two, we will cover the machine learning and the deep learning aspects of the image classification. Uh, since this is a practical session, uh, if you will get involved more and you will be having more queries, so we can design the tomorrow's like session according to you. So whatever image classification you are interested in, we can move on to that. I'll start with the basic one, and then we can, as you request, we can discuss that as well. So today we will start now. I will be opening my Google Chrome, and then we will start from the Colab sessions. Okay, I'm sharing the other screen. Is my screen visible?
Yeah, it's visible.
Okay, so first of all, you have to open your Google, basic Google, www.google.com, and then simply go on typing Colab, Colab. If you want, you can do it along with me, or you can just listen. So next, the first link which will open, we can directly click on that. And then as the screen opens, you can start with the new notebook. Okay. It will take a while upon for loading, and then we can quickly start. So this type of screen will open. So I'll just quickly demonstrate what it is. This is basically the coding cells. Suppose here we are going to type whatever the commands we have, like print hello. And by clicking this, we can execute that. And the results will be displayed on the screen. Okay, so this is a session which will look like when you will open in your notebook. And now for the today's purpose, I will start with, I have already made some notebook, so I'll quickly go on to that.
Dr. Aditi, sorry to interrupt you.
Yes, sir.
So we may ask the audience if they want some little time to pause here and they are doing it simultaneously, or we can proceed. So if
Okay,
anyone
sir.
is doing simultaneously and want some little time to pause here, so we can stop over here. Anyone can signal us like they are
Yes,
doing it simultaneously.
yes, sir, we are doing so. If we can get some time, 1 or 2 minutes.
Okay.
Yeah, yeah.
Okay, sir.
Simultaneously, others are all if others are also doing and if they are able to do that like hello world or hello printing something, or getting any doubt or any problem, they can share the screen. You can. Okay, Dr. Kishan, you are able to do it?
Sorry, we have to open new notebook now.
Yes.
Right.
Yeah, it's showing some notebook loading error or something.
Can you share your desktop screen so that we can see?
So sir, I was here.
Hmm.
Mm. So I came here and now I had started this file.
You have to click the new notebook when you are on this
Yeah,
page.
actually, yeah.
You can go to file and then you can directly open a
Yeah.
new notebook. It will be a blank notebook.
Yeah, this one.
Your video is
I'll
not
I'll
so.
demonstrate once again because I'm unable to see your screen clearly. I'll demonstrate once again, this time slowly, and then you can get along with me. Okay.
Yeah.
So first of all, we will open google.com, and then as we know, we have typed Colab, and then the first link which appears, welcome to Colab, Google Notebook. This type of link will appear, and then here on the downside left corner, there is a notebook plus sign with a new notebook. You can click that. Is the new notebook opened? Or if not, then you can also uh, click on the file and then you can open this new notebook in Drive. If the notebook
Do you
is
find
open,
it,
shall we test? Yes.
Dr. Kishan?
It,
Do you find it?
yeah, it's showing something like notebook loading error or
Can you using that software? Can you share your screen?
it's actually, sir, I am logging in my phone and I am doing this on my laptop actually.
Actually, in your camera, I'm not able to see.
I'll do one
Uh,
thing. I'll click the photo and put in the group, sir. Please see once. So I put in the group. Please see once. No?
mm, Actually, this is giving some error in your drive storage quota.
Okay, so
Whatever.
it might be full or something like that. So I should log in with some other Google account.
Yeah, then only you will be able to do it because it is giving some restriction over the storage quota. Like you have already adjusted the storage from your drive.
Okay, sir. I'll do from other Google link only
Yeah.
then.
Okay, Dr. Aditi, we may go forward.
Okay, sir. Okay. So as you have seen that the notebook is open, so what we will be doing is, first of all, we will be starting with the Python basics. So starting with, like, as you have opened the notebook already, so let's start by checking that what version of the Python is installed. Okay, so for that we will type import s by s and then print the Python version, print the Python version, and the command is s by s dot version. So you can run it along with me and you can see the latest Python version will be installed, that the Colab will be running on that 3.12, 3.12.12 version. Okay. So because in many cases, the issue is like if we are working with the Python, so there are some libraries or some modules which we have, like if we are working with the code which is already mentioned in the it is already available on the internet, then there are issues with the Python version. So suppose I am working in currently Python 3.12, but the Python version on which those modules were given, that is 3.10. So this is a major issue when working with the Python, one of the issues. But as the Python is progressing, Python versions are like they are coming up. So what they do is they are compatible with the old versions, but there are some libraries and some problems are there which are only resolved when we are in that same version. So for now onwards, I think it's better that if you are working on any Python project, then you should always opt for 3.10 or 3.11. Like the version which is ongoing, you should not move with that. The previous version, it will have all the libraries and everything will work well. So, okay. Now starting with the first and the very basic part of the Python, it is variables and data types. So we have four types of data types, that is int, float, string, and boolean. So now I will start by depicting that how we can write them. So let's suppose we take the variable age, and let's say the age is 30. Okay, this is a simple number, so this is a type of int. And then suppose we take a height, and let's suppose it is 170. 170 point maybe 65. Okay, and then let's take a name. Let's take a name. Let's take my name, Aditi. And since this is a string, so we have to put that in a inverted commas. Okay, height, because it has a decimal point, so this is called the float type. And the name, since it is a string, since it has a inverted comma, so it is a string. And then finally, let's go for the Boolean expression. So let's write, suppose is PhD, and the Boolean is true or false. True or false, or we can write it as 0 or 1. So now let's run this first of all. Okay. Now let's check what is the type. As I have already mentioned that age is of int type, we can also check that by typing type and age, because age is a variable we have written. We can, when we will write the type of age, it will give us the whatever the data type it belongs to. So let's also check the type of other variables which we have typed, like type of height is float, and again the type of, suppose, name is a string, and then type of this PhD variable, it will say Boolean. Okay, so this is the basic data type. And if you have to put, like here we have declared the variables, now you have to print the variables. So what is the method is, we can simply go with print age. Okay, it will give us 30. Or if we want that we like a variable name as well to be printed along with that, so we can say, suppose print name. Okay, and we can give any format or anything, but under in these inverted commas, and then we can write the variable name, which is name. So it will say name and the name variable which is there. Okay, so now here you have to see like simply when I was printing the name, I simply wrote whatever the variable name, and then I simply wrote this name and it got printed. Whatever the variable type it will be simply be printed. We don't have to explicitly mention the type of the variable. Like in the C language, whenever we are printing a string, we have to write %s. If we are if we are printing a number, we have to write %i. for the decimal or maybe the int type of variables. But in the Python, we have the flexibility that whatever the variables are there, we can simply print them. Okay. So now moving on to the second important concept, that is loops and conditions. Okay. So we all are familiar with that there are three types of loops, I guess, for, if else, and while. These are majorly used. So since this is an essential Python programming concepts I'm discussing, so I will go with the if else and the for loop. So let's start with the first loop, that is for loop. Okay. So let's say we have to see that if a number is positive or negative simply. So let's say I am printing, I'm having a number 90. I want to ask, are you able to understand what I'm writing, or should I increase my speed or decrease the speed, or is it okay?
It's fine.
Okay, thank you. So starting by declaring the variable, suppose num is equal to 90, and now I'll create a if else loop that if num is greater than or equal to 0, we can have both conditions, like we put greater than and equal to sign, equal to 0, and then we put the then we put the colon, which is used for indicating the if loop that the condition is complete. Like here our condition is only this one, so we, after this we have inserted this colon, and then we'll be moving to print the statement that suppose if it is true, then let's say it's positive, and then else. The major thing about Python and any other programming language also is that we have to take care of the indentation, because if I have suppose written print here, and let's suppose I'm completing this and this, it will give me an error, that indentation error. So we, for rectifying this, after the if loop, after the if condition has been there, then in the next line there has to be some space. You can simply put that space by pressing tab, which is tab key, and then again tab key, and then you can see as we have given the number 90, the result is positive. Now we can change this number. Suppose I give it -1, -10, and then this result will be giving us negative. So let's move on to another code example. Let's start with the code of even and odd. This was one of the major codes which was discussed in the college times whenever the Python programming or any C language programming was started. So let's start with for I in range. I'll discuss the range, what does this range does, but for now I'm just writing it. Where for I in range this, if the number whatever for I in range 1 to 11. Range 1 to 11, it is basically whatever the numbers which will be starting from 1 and then will the stop till 10. 11 will not be included. So if I %, this is a modulo operation. We will again discuss this later on, but I am just for depicting the use of for and if else, I am writing it here. And then we can print I is even. So you can see, okay, let me also mention the other numbers. Print I is not even. Just I am elaborating this so that we can clearly see which numbers are even and odd. So when this for loop will run, we can see that 1, it is not even, 2 is even, 3 is not, and so on up to 10. Why 10? Because we have given this number 11 and 11 is not included. Okay, so this is basic two examples of if and for loop. Okay, now moving on to this concept linking with the image analysis. So this simple logic will help us in traversing the frames when we will be dealing with the medical images. Suppose we are working with a video and it has a maybe 10 frames, and then we have to sort out what frame contains what images, and for that we need if else loop, and or we can go with the for loop. So now let's learn about the data structures. There are four type of data structures: list, tuple, dictionary, and set. But I will not be discussing about the set because it will be very confusing otherwise. So starting with the list, let's just quickly suppose I'm okay. So list starts. Let's When I am going to represent list, I will use this square brackets. And for tuple, suppose I am having some variable, it is represented with the round bracket. And suppose I have some variable named this with this curly bracket. So this is dictionary, this is tuple, and this is list. So now let's create. So there is a variable fruits. Let's write the name of some of the fruits. Apple and maybe kiwi. Dimension, let's say 10, 20. And now the dictionary. Dictionary has two things. One is a key, one is a value. So for representing the key, suppose name, and then we give its value Aditi, and let's suppose ID is the another object in this key value pair, and let's suppose it's 100. So let's check list. This is a list. So the list is this tuple and dictionary. For accessing a dictionary element, we can go with the name of the dictionary, and its ID, its key name, suppose name, and we can let's say print, because here I have printed when I'm printing the dictionary, all the elements are visible. But if I only want to see what's in the name, I can simply go on with this. Okay. So now list is a very flexible type of data structure. Here you can see I'm having this names. I can also have numbers in the list. Also I can have the string. In dictionary, again I can have the combination of other data types. Okay. So let's delve deeper into what other functions list can perform. So we have a list fruits. So if suppose I have to add some element, because this is a basic operation, because when we are working in medical analysis, medical images, suppose we are working with some frame and we have to extract that frame, or we have to do some operations on that frame, and then we have to append those frames into that, maybe an array type of a thing. So for that we need whatever the list of variable is there, and then we can simply append with the name, suppose like this. And now let's print fruits. You can see apple, kiwi, and mango is added. Okay. So
Yeah, sorry
is
to
there
interrupt you, Aditi. So,
yes, sir.
so any participants till now, if any doubt or want some little more time, 1 or 2 minutes to implement that, or if anything is there, we are here to listen you. Okay, I think all are able to do it. So please go on.
Yes. So you can see that with append keyword, I have added the mango at the last of the list. So there is a list, and whenever we append the last element, it is basically a type of a stack. Suppose number one apple, then kiwi, then mango, and whatever I will add, it will go on appending at the end of the list. So suppose if you want to insert some other fruit name, other element at some particular place. Okay, so for that we use fruits dot insert and whatever place, like already there are 3 places covered. So let's say at first place I want this fruit, maybe fruit orange. So you can see now it will be inserted in that particular place. Also, I want to mention that in the list, the numbering starts from 0. So this is a 0th element. This was first, this was second. So I have mentioned here that at first place it should be added. So according to that, the first number is of orange, like the second place, basically the second place, but the first location because it starts from the 0. So after that, if you want to remove some element, particular element, let's suppose fruits was the name of the list, and then I have to remove kiwi. Then let's print. You can see the kiwi will be removed. You simply have to give the name of that particular element and it will be removed. This is a very important concept because it is very, very helpful in image when we are working with the image frames and we have some conditions to apply. Like suppose if this condition is, maybe condition 1 is valid, then put it in list 1, and then if it is not valid, put it in list 2. So this is very helpful in discriminating maybe when we are working with the anomaly. So okay, the another important thing is, as you can see here, we have dimension, which was represented using this curly round bracket. So the good thing about dimension is it cannot be verified. It cannot be changed. It is immutable. If you have heard the word, it is immutable. So this is dimension. Suppose, okay. So let's say I am printing and suppose I have to, okay, before that, let's start with dictionary. Wait. Yeah. So for the dictionary, we have this element. We have already have this dictionary. Suppose we have to change the patient info. Patient info, maybe the ID is to be updated. So we can simply go with this equal to maybe 500. As you can see now ID is updated. Initially it was 100 and now it is 500. So the dictionary can be changed. So we can say it is mutable. Now moving on to our example, previous example of dimension. Dimension, if suppose I am trying, let's suppose quickly see the elements and then I want to modify the dimension element. Let's start with dimension element 0. 0th element can be updated to maybe 100. Let's see. So it will say the tuple is not supporting this type of assignment because it is immutable. So if you want to modify this, there is another method. Like let's suppose this is a yeah. Let's suppose we have another dimension which we want to add. Suppose it's 89. Okay. Another element, we will create this and then dimension 1, which was the previous one, and we can simply take its first element. Okay, and now see if we can print the dimension. So we cannot modify. Okay, we cannot modify the dimension. We cannot modify the dimension, but we can create a new dimension using this previous elements, and we can only like suppose here the dimension was 10, 20. So what I did was I replaced the first element with some another element, and I created a new dimension using this previous dimension's second element. Okay, so this is the concept where we can modify the tuple by storing it in a new variable. Now moving on to the Python operations, we have these 4 type of operations as you can see on the screen. Arithmetic operators which are simply plus minus, multiplication, divide, and this double backslash, it is for getting the int. Otherwise, if we are simply performing this, we will, like suppose we are doing 3 by 2, it will give us 1.5. But when we perform it with this, it will give us 1. It will remove that 0.5. So this is for accessing, this is a modulo operation, this is for accessing the remainder, and this is the power. Okay, now moving on to the comparison, this is equal to, if we are to compare some elements, if A is equal to B, so in this Python, we write it as double equal to, this is not equal to, less than, greater than, we have already done, less than equal to, greater than equal to. Logical is, these are very useful in the loops, so we can use them as it is, like and, or condition, not condition. And then finally assignment operators. If we have to replace some values, like in the dictionary case, what we did was we modified the patient infos ID and we simply assigned it using this equal to operation. So let's start with some example. Suppose for the arithmetic case, suppose we have these variables 15 and B is something maybe difficult. Yeah. Now let's see what these operations will do. For A plus B is, we can simply write the operation here. We don't have to create a new variable for storing this and then calling it again. Plus B A minus B. This is A multiplied by B. This is divide, which will give float result. This will give us int. Let's do B power A. Divide. Okay, A power B. Print. So A plus B 54, simply 46. Multiplication 200. As I already told that it will give float. Double will give the answer as int. So it will remove this 0.5. It will not round off, but it will simply ignore whatever it is after the point. So this is when we divide 50 by 4, we will get this and then this power, 50 raised to power 4. So now moving on to the comparison, operations. Suppose x is 10, y is maybe 20. Let's say we have to compare x equal to y. whatever is written in this inverted commas, it will be printed as it is. And this is the operation which we are requesting print function to perform and then give results. And then next is if, let's see, if x is not equal to y, not equal to y, is less than y. Let's see. So it is giving us Boolean. So if x is equal to y, it's false because it's not. If x is not equal to y, it's true. The condition is giving us true. If x is less than y, it is giving us true. And then let's check other operators. X greater than y, x greater than y. These conditions are helpful in if-else loop. If x is less than equal to y, okay. So this is comparison operators. Now moving on to the next type, which is logical operations. So let's declare two variables as maybe R variable is true, S is false. So checking if P, and I'm writing it as capital here because it will be only printed, P and Q, and then print P or Q, P. Let's write capital this time and see if it works. And print not P, not P. Okay, so it's giving us error that we cannot write it as this. We have to write it.
Ma'am, actually, the variables are R and S. It should be
Okay.
P and Q.
Okay. Thank you so much. Okay, so now it's okay. Let's again verify if that was working. No, it was not working. We have to write them as small. And also you can see when I was writing it as capital, it was not getting changed to blue. So this is an indication in Python that we are not, this is a basic variable name. And whenever that it changes color, then we can go with that that these are the inbuilt keywords which we can directly use. Okay. So here we have to write them as small. So and condition is when both have to be true. Either these are false, this is true, this is false, so we are getting false. Let's quickly check if both were, suppose Q and Q. Sorry, P and P, P and P. So the last one will now give us true. So these are basic Boolean expressions which you might be familiar with. Okay, now moving on to the next part, which is assignment operators. Okay, so assignment operators, suppose the number is 10. So print initial. Okay. Now let's apply the operation of assignment. Num plus equal to 5. So what will this do is it will simply add the 5 with the number. Okay. Now let's see after plus equal to the number is simply num. Okay. So initially it was 10, and then I performed the operation num equal to num plus 5, which is written as num plus equal to 5. Okay. So after it became 15. Now again, let's start with num1. Suppose it's 20, and let's perform some other operation. Let's suppose this equal to 2. So what do you think this will do? It will simply multiply the number with 2. Okay. It will simply multiply the number with 2. So let's start with, let's write after this. Was 10 and then it got multiplied by 2. Okay, so it got multiplied by 2 and we got 40. Now moving on to other operation, num, maybe this time negative, this equal to 4. Oh, sorry. Num equal to maybe num2 is equal to 5. And now let's perform the operation minus, okay, equal to 7. Print num minus equal to, so now it is minus 2, because initially the number was 5, and then what we did was we updated the number with num minus 7. Okay, so we updated the number as 7, so it is 5 minus 7 is minus 2. Okay, so let's quickly write a program which will cover all these things. Let's suppose age is 25, is PhD true. Okay, wait. So let's write maybe adult. It will get stored automatically. Okay, if age is 25, now we are creating a variable is adult, which is based upon the previous variable, which is saying age. It's better to put these brackets so that we can clearly see what's happening. Okay, so now can drive is adult. It should be adult and if it's true. Okay, this is a condition which I have written. So we can simply go on printing what was the age as we have did before. Print is adult with the variable adult, and then can drive. So let's see. So age is 25 is adult. It was true, and that's why in this sentence, and sorry, in this variable, this was already a Boolean variable. So I simply clubbed it with another Boolean variable using and we can see it's giving us the result. So this is like we are using different types in one example. Okay. So now moving on to the next important concept of the function. So as we all know that function, it is a reusable block of the code which performs a specific task. So rather than using it again and again, we can simply create a function and then let it like call it whenever we want. So this is a basic syntax in which we define we use a def keyword and return keyword if we want anything, the function wants anything in return. So this is a function name. These are the parameters which are passed, and this is the code. So let's start with the basic example. So let's create a function workshop. Okay. So this is the name of the function. This will define if there are any parameters to be passed, or it can be empty as well. Okay. And now what I want is whenever I want, I call this function. So it should print. So it should print hello. CSIR-CSIO workshop. Okay, so let's call this function now. This is not returning anything. Okay, so simply what we have to do is we have to call this function. All right, now let's pass something in it as a variable. Let's suppose I am passing the name. Okay, let's not specify. Let's write it like this. Hello, this, and then name, comma, hello, and then name, and then this workshop, and let's type again this. Let's see now. Now it's printing hello. Okay. So here we have not passed any of the parameter, and we are not returning as such anything. Whatever the message is printed in this, it is simply showing up. Okay, now here we have passed the variable, or we can say we have passed the argument. We have passed the parameter, or maybe we have passed the argument. Okay, so now let's write a function which can return a value. Okay, so let's add by 100, and maybe we are passing some parameter, and now the result is t plus 100, and return the result. Okay. Let's call add by 100 equal to 90. So, but here we did is we passed a variable d, and then in that function it got incremented by 100, and we simply returning the result. So when we are calling this function with that particular, with any argument, when any argument, let's suppose we are using this again, and we are passing negative number. So it will give us the number minus 100, and we'll get the answer. So this is when a function is returning a value. Okay, now let's start. Now let's finally discuss about one of the good examples of using this function. This is recursion. Recursion is when we are using a function again and again. Means the function is calling itself. So let's start. Suppose there is a number in which can anyone give a example where a function is calling itself? A very basic mathematical function is there, in which a function, whatever suppose I have defined, it will again be calling itself again and again. Any example you can give, anyone? Okay, I'll give a result and then you can name the example. Okay, so there is a function in maths in which when we are giving it suppose 1, it is giving us 1. If we are giving it 3, it is giving us 3 cross 2. If we are giving it 9, maybe it is giving us result as 9 cross 8 cross 7, so on up to 1. So any idea what this function is? Okay, no problem. I'm talking about factorial. This is a very major thing in maths. So let's define a function factorial. So if but the number which I'm passing, if that is equal to 0 or the num is equal to 1, what we want as answer is simply return 1, because 0 factorial is also 1, we know, and 1 factorial is also 1. Else we can simply return the number itself multiplied by, again I'm calling this function with 1 minus. So you can see either it is 0 or 1, it is giving us 1, and else it is, suppose I'm talking about 5 factorial. So the result will be 5 factorial, 5 cross 4 factorial. We can write 5 factorial as 5 cross 4 factorial. So let's see if this is working. Factorial maybe 5. Anyone can name what's the answer for factorial 5 so that we can verify? Anji, please, anyone? What's 5 factorial? Anji, anyone?
120.
Yes, it's 120. So let's run this and see we are getting this answer as 120. So what we did is we have created a recursive program where a function is calling itself in the function definition. So we defined the function that it will return 1, and then here in the final we are again calling it, because as the number is getting decreased, what it will finally end up at 0 or 1, and it can finally return to the main definition. So now let's quickly work upon some inbuilt functions which I mentioned. So let's start with range. Suppose for I in range 1, 6. So as I have demonstrated earlier, that 6 will not be included. So let's simply print I. So let's see 1 to 5 it is simply. Now next important thing is, which I want to discuss, is enumerate function. Okay, so let's say we had this now fruits. We had created this fruit list. Now what I want is I want to enumerate it. What I'm saying is enumerate. Okay, so for this I will write for I comma, let's suppose I name a variable as fruit. Okay, in enumerate fruits. Okay, and it will simply I comma fruit. So upon running this, you can see the number is assigned for 0th index, maybe for the first and for the second. This is very helpful in the image processing operations. You will see in the next session. Okay. Now the next important concept which I want to discuss is list comprehension. This is a advanced concept, but since we will be moving to the advanced concepts tomorrow, so this is very beneficial. So let's say I am list comprehension is basically when we are making a, like when we are using if else in just one statement. Okay, now I'll just depict it here. Since it is a list comprehension, so we have to use the curly square bracket, and then this is an example x comma x. So we need the result x comma x. Okay, so what is the x? So here I will define for x in range 1, 6. So we have used the simple that range function also, and we are using the list also, and this is list comprehension. Now let's print what's t. So for the first number was 1, it remained 1. For the second number 2, it got multiplied by itself, and then the third element 9, fourth became 16, and 5 became 25. So for x in range this, if I had not used the list comprehension, what would have I done? I would have first wrote this, and then in this loop I would have written that okay, now increment I or multiply I with itself. So it takes a lot of space also, because Python is an efficient programming language if we use it properly. So list comprehension avoids loading of these variables multiple times, and also it saves the space. So this is a very good concept. If you use this type of a thing, that it can really help. So now moving on to that next concept, that is NumPy arrays, which is a foundation of image data, because images are stored in numerical matrices. So let's see how to use them. For that numpy, let's start with import numpy as np. This is how we use this library. This is an inbuilt library of Python. Let's quickly load it. Now moving on to, let's define an array. So as we have used this numpy as np, so we can, for accessing that anything present in that library, we can simply use np dot, suppose there is a function array and we have to create maybe 10, 20, 30, 40, 50, 80, 40. Print that. So this is an array. Now next, talk about if I want to access some particular elements of the array. Not all the array elements to be printed, but some elements. Okay. So for that, I will do square bracket and then from the element I want till the element I want to get it printed. So you can see I wanted first element till 5. So this was the 0th index, 1, 2, 3, 4. Till this I'm considering this list. Print array. Let's only write this. It will print first 5 elements, okay? And if you want the last element, suppose, so it is starting from third and then it is printing till end, okay? So starting from the third element, this is 0, this is 1, this is 2, and this, it is starting from the third. And then next is, I want the elements to be printed, but with the step of 2. So first element will be printed, then next it will skip 1, and then the second element, it will again skip 1, then the next element, right, and then the last element, okay? Now, if you want that the array should be printed in reverse order, what we do is we simply type this. You can see this basic numpy array is reversed. And if I simply type this, that all the elements I want, so it will simply print all the elements. So I'll just quickly explain what's happening. These columns are used to depict that what elements we want. Okay, so in this first example, what we did was we wanted element number starting from the first and till the fifth element. So starting from the first, remember it starts from 0th. It has the 0th index. Okay, so first element, second element, third, and the fourth element was printed, which is ideally the fifth one. Okay, now till the fifth element is printed. Now from the third onwards is printed. So we are using it as 3 and then the colon. And then all the elements, but with the step of 2. And then for reversing the list, we are using this one. And for accessing all the elements. Okay, now this is a basic declaration that how we declare an array. Now moving on to what we will be using in the image part, because there we have a matrix. This was a 1D array. It means it has one row and multiple columns. Okay, this had a single row and multiple columns. Like column 1 contains 50, or column 1 contains 40, then 50, then 80. Okay, now let's make an numpy array which is a matrix. Okay, so maybe the array matrix. So 3 dot. For that we need 1, 2, 5, 7, 10. Let's quickly print that. So as you can see that we have created a matrix which contains this element as a first row, these two elements as second row, and these two as third row. So again, we can perform all these operations. And also, yes, I forgot to mention that these are the slicing operations, which is again NumPy slicing. You are slicing the list. You are either accessing some of its element or you are accessing the elements in reverse. So these all are part of slicing. Okay. So now let's slice this particular matrix. Suppose I want, okay, let's extend it by one more dimension. Be easy. Just a minute, please. Okay, sorry for the interruption. So here I printed this matrix. Now let's start with the slicing operations. Suppose I want the elements to be printed. Okay, we have read the slicing operations. Now let's start with the other operations. We can simply print an array. We know. Now let's suppose we want to know the shape of this matrix. Okay, so for that we will simply write the name of the variable in which the array is there dot shape. So you can see there are 4 rows and 3 columns. So the shape is 4,3. And this, as you can see here, it is returned in this round bracket. So this is a tuple and we cannot modify it. Okay. So this is the use of tuple, that when we are suppose accessing some of the object's properties, attributes, so we can not change them. So this is that's why the Python is also storing it is in the tuple. Now moving on to the next one. Suppose we have to compute the mean of these elements. Okay, so for that, let's start with NP. NP is the library which has all these functions already there. So NP dot mean function we have to use, and then this one. Let's see what's the mean. So it is simply summing all the elements and then divided by the number of elements. Okay, and okay, so now a quick hands-on task. Can you create an array? It's up to you, 1D array or 2D array you want, and then you can quickly calculate its mean and the standard deviation. I want you to perform this. For the mean, we have already used the keyword np.mean, and for the standard deviation, the word is np.std. np.standard deviation. Okay. So I want you to quickly go with that. Create an array yourself and then compute its mean and matrix and its standard deviation. This is the last task, and then we will start with the plotting and reading the data, and then moving on to the image processing. Okay, I'll give you an example, and then you can tell me that what's the mean of this particular array. np dot okay, compute its mean and standard deviation. If you are performing, please let me know. Okay, you simply have to do is np.mean of this array, and then next you can simply type np.standard deviation. Okay, so this is a big number. Now let's start with the matplotlib library, which helps in visualizing the data so that we can see what the data looks like, because it is very important in signal as well as in image processing. So let's start with an example. First of all, we have to import the libraries. So matplot lib.py plot as plt, and then although we have imported the numpy, but we will again be using that, so that's why. Let's create a variable xa. Suppose now again I'm using a new function here. It will create multiple points starting from 0 till maybe 200. 200 is the last point. And how many points I want? Maybe I want 15 points. So I want 0 till 200. This is like starting point and the end point, and 15 points I want in between. Or maybe let's make it to 25. And then the next variable is np dot sine trigonometric sine function. And now let's plot that. Okay, plt dot plot xa comma xy. Xa comma xy. plt dot title sine. This is how we give the title of the curve. For plotting, we first write the x-axis and then we write the y-axis. So x-axis is the number of points. Here it is depicted using the linspace command. And then xb, it is the function which we have to plot. Maybe it is sine, cos, or any function which is based upon the points given in the x-axis. This is the title, and this is how we give the label, x label, x plt dot y label. Finally, if you want, then we can use that as a grid. If you want the lines to appear like in the graph we plot. And finally, plt dot show. This is a sine curve, although it is not looking proper sine curve. Let's change the dimension here. 2 into np dot pi. Maybe 250 points. Now it will look like a sine curve. Okay. So what we have is, on the x-axis we have the points. On the y-axis we have the curve which is plotted. As you can see, we have given the title of sine curve, and then we have on the y-axis we have again given it as sine. So this is how we use the matplotlib library. Once we have plotted, we can add the things we want to see on the curve, and then finally we write plt.show. Okay. Now let's move on to reading the CSV data. Let's quickly create a dictionary. Okay. I hope you know dictionary, but for that, like, we have to read the CSV data. For that, we need another important library, which is pandas. So importing pandas as PD. So let's create the data. Let's create the data. I'm now creating a dictionary which has the keyword patient ID. And for that, we know the format AB10. Now next key value pair I will be writing, which is age. For that again, the declaration is like this. 30. And now let's add one more element. which is diagnosis. This is the proper syntax. Maybe this is abnormal, and it has some type of a pneumonia. Okay, the spellings are incorrect, but you can ignore that. Now, for calling the data, converting that into the data frame. Okay, so first of all, let's print simply the data. It will be a dictionary, and then converting it to the data frame. dd dot data frame. It is a inbuilt function of the pandas, and let's see how it will look like. And then finally, we have to convert it to CSV. dd to CSV. This is a file, patients.csv. Comma x false. So first of all, it printed the direct dictionary, and then it converted into the data frame. You can see it has properly, it is like looking like what the data will look like maybe in the Excel sheet. It has a particular serial number, and then the columns are arranged properly and with the elements of the data. Now we have saved that into patients.csv, and we can read that from that using pd dot read underscore csv. Okay, this file name like this. So you can read that, and it will be showing like this. Okay, so this is so far the Python basics, which we need for covering the other important aspects of this particular session of medical analysis. So I think time is up, and it is a break time.
Yeah, we can have a short break. So
Yes,
we
sir.
will get back by 3:30. So this is a short break of 15 minutes. So we will get back by 3:30. Thank you.
Okay. Thank you.
Okay, welcome back, participants. So, Dr. Aditi, have you joined? Yeah. So, welcome back, participants. So, now we can start the session. Over
Sir,
to you,
is my
Dr.
screen
Aditi.
visible?
Yeah, yeah.
Okay, sir. Okay, so far we have covered the Python basics, in which we have discussed about the variable and its data types, the loops and conditions which are there, data structures. Moving on to the Python operations which are available, functions in Python, in which we have discussed how to make the functions and also some inbuilt functions which will be useful, like range, enumerate, and the list comprehension. Then we discussed about the NumPy arrays. NumPy arrays, how they are declared, and then the slicing operations, and then how to declare a matrix. We performed the task of computing its mean and standard deviation, and we also we tried plotting the sine curve using the matplotlib library. And then finally, we ended up in the previous session on reading the CSV data, where we first declared the data as a dictionary file. Usually the data is already given like in the CSV format. What we have to do is we have to read that, and then we have to perform like the reverse steps. Like here, what we did was there was a data, and then we converted that into the data frame, and then we imported that to the CSV file. But if we have the CSV file, what we have to do is we have to read that file using this command, and then we have to convert that into the data frame, and then we can work upon that. So now, finally, moving on to the medical analysis part, in which we will be not moving on to the medical analysis, but moving on to the first step towards the medical analysis, in which we will be analyzing the images as an arrays. So this is the foundation of image processing. So what are images? Images are basically they are the digital images are basically the matrices of number. We have various scales. Like here we declared the matrix. There are some numbers, like here we have declared the matrix, but in case of the digital image, these numbers will represent the pixel intensity. Okay, so the smallest part of any image is pixel. So here also, suppose we can represent an image as an array. So any number which is the smallest one, it will be a pixel. Not any number, but any element which creates an image. Okay, so moving on to the next concept, in which here I have simply written a small program so that we can quickly go upon that and discuss that. Okay, so that we can move on to our next module. So here what I am doing is I am importing a NumPy library and then matplotlib library as PLT. I have written PLT, otherwise I have to write this every time when I am using maybe PLT. I'm like showing the command, or maybe I am plotting the command. Okay, so what we do is we give a small keyword so that we can use that. We can also give it as simple p, and we can use that. Okay, so whatever you right after as, you can use that. So here what I'm doing is I'm creating an image of 5 cross 5 matrix, 5 cross 5 dimension, matlab 5 rows and 5 columns. So here I'm using since I don't have an image right now for this example, so I'm introducing one more keyword of the NumPy library, which is random rand int. Okay, so what will it do is it will create a 5 cross 5 matrix which will contain the numbers from 0 to 256. And remember, 256 is not included. It will be up to 0 to 255. So in any image, when we are talking about a grayscale image, as it is written here, so 256 cross 256 grayscale image, it is basically, it has 256 rows and 256 columns. Okay, So, and each element will vary between 0 to 255. And if it is an RGB image, it will be a 3D array and it will have a third dimension. Okay. So here I'm generating a matrix of dimension 5 cross 5. 0 to 256 will be the range, and data type is uint8 because in the images the data type is uint8. You have to write that if you are creating an array, if you are creating an image using this, okay, this command. So let's quickly see how it is. Okay, so it is already printed image as an array. So if I will again run that, it will be a new numbers. So that is the magic of this random. So every time I run this command, the new type of image will be generated. Okay. Even if when you will write this command in your Colab, every time it will create a new type of a matrix, which is a 5 cross 5. Okay. So what I'm doing here is I'm printing image as an array, and then in next line I'm printing image. Image is basically what numbers I have given that. So you can see here it is 5 cross 5. You can also go with maybe 6 cross 6. Let's try with 6 cross 6, or maybe 6 comma 5. Let's see. So it is 5 rows and 6 columns. And now let's display. How will we display? We will use the command IMShow because we are talking about the image and we have like we have given this data type uint8. So we are using IMShow plt.imshow plt.title color bar and show. In the previous example, it was a 1D type of example, so we did with plt.plot. Here, since it is a 2D, image is 2D, so we are using IMShow and image, and we want the CMap. Like CMap is basically what visualization you want. So here I want the gray visualization. So this is the title, this is the color bar, which is represented along with the image. It represents that 0 pixels are the dark pixels, and as we move on to the 255 number, here it is mentioned till 250, but there is some space over above that this particular mark. So it is basically up to 255. So the maximum as we go towards the 255, it will represent the white element. Okay, so as you can see, like in this image, there is number 6 over here. It will be a darker number. So this is the maybe 6 number is represented here. So it is a darker. As we are going towards 0, it is representing dark. And now moving on to like see 252, here it is white. It is tending towards white, not fully white, but it's 252, so it's towards white. So this is how we create an image and we represent an image. And now let's try some basic operations on the image. Let's suppose we have to brighten this image. Okay, so this was the image array, image data which you are seeing, and we have to add 50 in each of the elements. Okay, so what we do is we do use the clip command np.clip because we don't want the array to exceed beyond 255. Like we are already giving the limits to 255. We have created an array with the limit of 0 to 255. Okay, and in an image also, if we are brightening, like we are brightening the image, it is not like that the number is 255, it will be increased to maybe 300. No, it has the limit and it has to be up to 255 because once you are brightening an image, there is nothing up beyond white, right? So that's why we are using here the clip command np.clip image plus 50, and what the range we want is we want the range till 0 to 255. And now in the next example, I'm performing a thresholded array. I'm performing a thresholding. Now here I'm using a command np.where. So this is basically I want those points in which the image that particular when I am writing an image, it means every element is okay. Every element is meant is will be used. So every element, every element of this image where the value is greater than 128. Okay, so these are the points of will be thresholded. And now let's say how to plot them. So here I'm using this command. So what it is doing is, so far we were only generating a single plot, plt.plot, and image was popping up. So here I want in a single figure Like you can see in a single figure, 3 plots are there. So these are represented using PLT dot subplots 1, 3, and then the figure size is 10, 3. Okay, we can change that. Okay, I'll change that in another example. Let's suppose I'm going with the same command, and let's say it is 3, 30. Okay, let's see what will it do. So as you can see, it has increased the size. Okay, so here I want 3 subplots. 1, 2, 3 means 1 row, and there should be 3 columns. I can also do 2, 2. Okay, so you can see now the whole image, which is of figure size 50, 30, will be divided into 2 sections, 2 rows and 2 columns. Okay, this is using this command, and this is how you write it, figure and axis. And then on the first axis, x0, ax0, you want to show the image, basic image. And on the axis 1, you want to show the brighter image. And on the axis 2, you want to show the thresholded. I'll write it once again so that it's clear. On the first axis, I want this. Let's comment it for the time being. Okay. So basically, now there are 4 plots. On the first plot, it will be the image. On the second, it will be the brighter. On third will be the threshold. Fourth one, since we don't have fourth one, it will be empty. Okay, so I'm missing something here. I have not imported the libraries. Wait. Hmm. There is some error. Just a minute. Okay, let's just skip. I am unable to see what's the problem right now. So as you can see on the first axis, on this first, we were plotting the image. On the second, the brighter is there. On the third one, the thresholded one is the plotted. So thresholded is where we have simply applied the operation that the pixels which are greater than 128 should be plotted. So what the number is there, we can just verify. Let's suppose we want this. So these are the pixels, and when I am going with the thresholded, so as you can see, there are some zero numbers, so they are simply the black one, and then there is 255. Okay, so here it is basically the numbers which are greater than 128 are simply converted to 255, and the numbers which are less than 128 are simply converted to 0. So this is how the thresholding is done. So as you can see, this is the matrix. Okay, now moving on to the next module, which is the image processing operations in Python. Okay, so this was the basic that how the NumPy can be used for analyzing the images. Now moving on to our session 2, module 2. So far, if you are having any doubt in this particular notebook, you can let me know. And also by the end of this session, I will share this notebook with you so that you can practice. If you don't have any doubt, I can move forward. Okay. So moving on to the second, which is image processing operations in Python. Now let's start with importing the libraries. But which libraries which will be used in this particular session? So first of all is computer vision library. That this is import CV2, and then NumPy, SNP, and then we need matplotlib. as dy plot as plt, and then there is library sky image import data. I'll let you know that what these will do, but for now I'm just writing them. So here it is CV2, NumPy you know, Matplotlib you know, and this is a module from which we want the data, the color, the filters, and the exposure. Okay, these will be used later on. So now let's first of all see what type of data is there. So we are using this one, and now let's see what is the data present. Print dir directory of the data. Okay. Since it's difficult to see that these are so many names, so let's try with enumerate, which we have used in the earlier notebook. Sky image dot data as data. First of all, we have to import this. Now let's write the function where I can, since you can see here, this is a list which is given. So now I want to convert it into an indexed list. So what we do is i.img in enumerate the data which is in dir.data, and now let's simply print that along with its num. So will it work? Anyone? What do you think? Will it give an error or it will run smoothly? Please, I need an input. Will this command run or not? Anji, please, anyone? If yes, then okay. If not, then why? I'll give you 1 minute and then I'll move forward.
Can you please repeat the question?
Yeah, I'm saying that will this commands run or not, or will they will give an error? Okay,
Am I
I'll
audible?
just yes,
Hello.
yes, yes, you're
Actually,
audible.
ma'am, actually, I'm getting a lots of disturbance from my end. Network issues is there. So
Okay,
on after one line of your communication, it is hello. Am I audible?
yes, yes, you're audible.
That's why I'm unable to answer.
Okay, you're unable to
If
answer. It means, yeah, I think it means that you might be getting that what I'm asking. You might be knowing what the error is.
uh, hel- 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 oh,
You can
hel-
write in
hel-
chat.
hel-
If you can write in chat. Okay, I'm assuming that you were able to check what was the error. So here I have not, so let's run it. So I was missing this. Now I have inserted that. Now again it will say the indentation error. So I'll just go with this and then press tab, and then now you can see the list which was previously printed, it has been enumerated. So you can see that in this particular directory, we have astronaut, binary blobs, brain, and these type of images are present. Okay. So now let's quickly move on to, let's display and plot this one of the image. Okay, so let's suppose the data is, as you can see, it was in dir data, and we have imported import sky image data as data. So we can simply use the word data. Okay, and in that data object we have these many images. So how can we access that? We can simply write image1 dot astronaut, which was present at the 0th index. Okay, and now let's print the shape of this data. How can we access the shape? We can simply write this, and also we can write image shape so that we know what it is printing. Okay, what I'm missing here. Okay, since it is an object, so I have to put this. So now it is 512 cross 512, means 512 is the length, or maybe it's the height and the width, and 3 represents that it is an RGB image. So let's plot it quickly and see. Since we have already imported the matplotlib, so we can simply write as plt dot imshow dot the name of the image variable. Okay, now plt dot title, maybe it's original. I'm writing it because we will be performing the operations later on, so it will be easy for us to see what image we are working on. Okay, we don't need access, so we have turned off them, and then finally plt dot show. Let's see the image of the astronaut. Now what's okay, I forgot to run. So now this is the beauty of Colab. Like here, I simply imported this directory and I plotted, I was able to run this. But since I forgot to run that, on using this particular library, I was popped with the error. Otherwise, it would have simply be like it would be smoothly be ran unless I required this particular cell. So now that I have imported this, I can go on, and it is already imported and we can see the image. So this is the image of the astronaut. Simply, this is how we display an image. And first of all, we how load an image, and then we how display an image. Now let's try with some another image. Maybe image2 is equal to, let's go with what other were available. Let's go with maybe cat. Image2, how we will write is data dot cat, and let's copy that to change the variable. And okay, so this is the image of the cat. Now moving on to okay, what do you think the shape of this cat image will be? Is it RCB or gray image? So this is looking like it is uncolored image, so it is RGB. Yeah. What were you saying? Sorry. Please repeat.
No, it is the RGB image, but the
RGB.
dimensions will not be equal because it's rectangular.
Okay. Let's verify. Print image2 dot shape. So you are right. It has 300 and 451, which is unequal. Now, okay. Now let's move on to the next operation of converting this particular images into grayscale. So how we do that is, let's say I'm converting the image 1 to grayscale. So we will use the keyword color.rgb to gray and the image 1. And let's write same for the image 2 as well. Color.rgb, since we are simply have to convert it to gray, so the keyword is simple. The color.rgb and image 2. Now let's plot that. So you can see what happened. RGB to gray, I am sure it was converted, but since the visualization we have to control, so here I will write map gray, and again map equal to gray. Okay. Now it's okay. RGB1 is working well. RGB2 it is given an error. So now these images were converted into RGB and we can see them properly with the CMAP. Previously also it was converted, but the CMAP visualization was not correct. Pixels, you will be having the values from 0 to 255, but the visualization tool was not showing that well. For that, we need this to be written along with the IM show. Now moving on to the next topic. Okay, also quickly, in the grayscale, what we do is we simply discard that colored ones and we have converted them into the two channels of 0 and 1, black and white. Okay, so this is a common operation which we perform while dealing with the CT, MRI, X-rays. Okay, so now moving on to the next session in which we will resize and crop the image. So for that, let's start with writing an operation where, let's say, image1 dot shape. We know what will it print. It will print this. Now, if I want to access its first element, image1 dot shape and its first element. Not first, because since it is a tuple and the tuple also indexing starts from 0. So if I have to access its first element, so I have to write this like this, here brackets and 0. Now it's 512. Let's take the another case because it was having unequal dimension. So in that case, it was 300. I'll write img2.shape so that we can see it is 300, 451. And now how can we access image and its second dimension? We simply have to write 1. So it is 451. Now these operations will be used in resizing. Okay, so first of all, suppose we have to resize the image maybe to half of its size. So what we can do is we can create a variable and we can use the CV2 library and use the operation resize, in which we can perform it on maybe the second image. And what we want to do is we have to, since we have to reduce it to half, so we will use its first dimension and its second by 2. This one, okay. Let's see. So it is throwing an error because it can only read the int values. Like we were initially also when we were converting it or thresholding it or clipping it, we were mentioning that it should lie between 0 to 255. Here, if I am not giving this operation, if I am simply dividing it, it is giving the float answer, and that's why it is giving us an error. Now it will work correctly. Okay, now moving on to this is the size that like this is we want is how we resize. Now we have to crop the image. Now for cropping, let's store these dimensions in some variables since it was an it's already converted. G dot shape. Third dimension I don't need, but I'm still writing it. Here since it is a colored image, so I have to mention this, but as I am working with this maybe the converted image. And for accessing its dimension, I can simply write h1, w1 because it has been reduced to 2 dimensions. It will run correctly. Okay, it's not running. Similar values to unpack. Yeah. So now it's running. When I am talking about the colored image, I have to give the third dimension, otherwise it will throw an error because it will say too many values to unpack because it is having 3 values, but we are only requiring the 2 values. So for that, we are giving the third dimension as underscore, which we did earlier. Now it will run. And for the grayscale image, since it has 2 dimension, if I will give the third dimension, let's see if it throws the error. Yes, it will throw an error because it is saying that expected is 3, but you are getting 2. Like here, you are expecting 3, but you have the two values. So for that, we have to see that if we are working with the grayscale image, we will be having the 2 dimensions. Okay, now it will run. So now moving on to the cropping part. So we have these, what is the size of the image in these H and W. Okay, now for cropping, let's say I create a variable crop and I have the name of the image as image2. Now what I want to do is the dimension. Let's work with maybe colored image. Dimension will be reduced to half and then a center cropping is there. I'll explain this operation. Let me write it first. This W2 okay. So here what I'm doing is for this particular image, which is RGB image, I am dividing it the dimension by 2 and then I'm computing its center point. Okay, first of all I'm computing its center point and then I'm moving 100 points and then again center point I'm moving 100 points. So from suppose a center is there and then I have moved across the right and across the left. Okay, and again in the next part h by 2 minus 100 shift on to plus 100 for w by 2 minus okay. So here I'm writing is from this point, from the maybe left point till the right point of 100 across 100 and then again across the width also 100 to 100. And then for the third dimension, I want to keep it as it is. If I'm working for this grayscale, let's write it for the grayscale as well. For the grayscale, I don't need to write this one. And also I have to replace the image name with the proper image name, which is the grayscale. Okay. Now this will run and now let's plot them. Okay, we can plot them across so that we can see what happened in the both grayscale or maybe the another one. So what we have to do is we have to write this dot plt dot subplot. Let's go with 4 subplots or maybe 2 subplots. Let's only go with one image. Big size. Big size maybe these size is in inches. And you can also set a dimension of DPI, maybe 500, default is 100. And now for the 0th axis, let's start with IM show. Let's see 3 images. IM show, we had the resized one. Where is resized? Yeah, resized image. Now have to set its title so that we know what it what this image belongs to. Resized to, we were reducing that size. Now on the first, let's see. Just a second, 0, 1, and 2. Can anyone help me out in removing this error? So let's again check together. So here I have declared the variables plt dot subplot. It is subplot. So now image is not visible. plt dot subplots 2, 2 we want on a figure of 10, 4 with the DPI of 500. On the first image we want image dot resized. Okay, it's correct. And we want to set its Has anyone wanted to say something? Anyone?
No, I think that was some mistake due to some participants.
Okay, sir. Okay. Okay, so let's resolve this error. We have declared the images, and now in this step, we are giving that in which segment to plot what IM show resized image. Let's see if it's plotting as no attribute IM show. So what can be the error? It is saying that IM show is not an attribute. Can anyone help? Okay. Let's go and quickly see if it was running before. I am shape and I am show. Yeah, it was running well. Was running. Was running. But to it has no checked. Let's simply plot Okay, we will move on. We will resolve this error later on. I don't know what's happening right now. Okay, no issues. I'll just take a minute or more. I'll see. So I have the resized image, just proper. We need to resize IN2 is resized, and then we are accessing its elements, colored, and another one. We have this image H2. Let's check its size. For out IMG that shape. Okay, so you can see that we have cropped the image. We are unable to plot it right now, but no issues. And again, let's check for this as well. Okay. So now here it's working. It is the resized image and this is the cropped center, which we performed by taking the midpoint and then moving across 100 image in the right side, 100 towards left, and same for the width axis. Now moving on to the next part where we will be flipping and rotating the images. Now, see, this part is an important part because this is what helps in data augmentation. Because when we have, suppose, limited data, not limited, but we have data and we want our algorithm model to learn. So what we can do with the images is we can, like for the case of signals, what we can do is we can add the noise. Same here with the image, we have this advantage that we can add the noise for extending the data set, and also we can like flip the images and rotate the images so that we can make our model learn better. So now let's start with flipping and rotating these images. So first of all, I want to introduce the flipping and rotating using the simple basic NumPy array. So let's start with simply, we have already imported the NumPy array. Copy that from the previous session. Suppose we have this array. Let's quickly print that. Okay, now let's flip it around. So for that, for horizontal flipping, what we will do is we will use the flip operation and we will use the image matrix, which is named array matrix, and we use this dimension and we will simply print it. Okay. So you can see here it is flipped horizontally. On you can see here the 9, 10 and 9 has become the first row now, and 100, 20 and 6 has become the second row. So it is flipped across the x-axis. So it is horizontal flipping. And now moving on to the next part, which is the vertical flipping. For the vertical flip, what we have to do is we have to simply use np dot flip and again the name of the matrix, and this time using 1. Vertical flip. Now you can see it is flipped vertically. This third column is now first column, and the first column is now the third column. And also we can flip it with the 180-degree rotation, and for that we can give here -1. which it will not be visible in this matrix clearly. So we will see that in the image part. So now let's work with the image. So if I have to flip horizontally, let's see CV2 dot flip, and we have image 2 and 1. Let's do the vertical flipping with the 0. And now let's rotate the image. And for that, we have the keyword 02 dot rotate, and we have to rotate it, maybe suppose clockwise. Now run this, and now let's plot this. This time we will see if it is correct or not. Subplots 1,3 with the fig size. This time maybe 12,4. To write in small letters. One comma 3, maybe 12,4. Okay. Now I will use a different type for viewing this. Let me store titles in my list first of all. Now I'm using this, and I've combined all that titles. Since now it is a for loop, so we have to terminate it using this column. A, T, C, title, in this. Now A dot I am show I am A dot set as T, which is present for A, T, and I am in this zip. And this three things are present. One is AX, one is title, and one is the name of the stored variables. And then finally, X is as off. And then when this loops end, we have to show that. So this was the horizontal flipping, this was the vertical, and this was the rotated 90 degree. And the original image looked like this. The first case horizontal, vertical, and rotated. This is very helpful in data augmentation. Now next, moving on to the brightness and the contrast adjustment part. So let's say, first of all, we have the gray image. Let's create its copy, okay, so that we don't alter it, the same image. Gray image, new maybe, and gray image 2 dot copy. Here also, when you are applying this, you don't have, because here the task was we were flipping that and we were storing it in some variable already. So the original was not altered. Here also, if I am plotting the original image, it will be as it is. But as we are performing this brightness and contrast adjustments on the image, on the real image, on the true image maybe, so what we need to do first is we have to create its copy. So by copying that, the operations will be performed on the copied version and the original image will stay as it is. So first of all, its copy is created, and then moving on to the brighter image, maybe brightening image this. So for that, again, we have to use the clip command, which we used earlier. And for that gray image, new, we will add some number and we will make sure that it is between 0 to 1, because we don't have, because in grayscale we have two extreme scales, right? So for that, the two outer scales are mentioned. Like in the previous case also, when we were performing maybe thresholding, we mentioned that 0 to 256 is the range. So this is the range, start and end, and the brightness will be improved. Okay, so now this is the case for brightening, and for darkening the image, what we do is we will subtract it. We will write the same, and here we can maybe subtract, we can do it 0.5. So let's view them first of all. Now we need only, okay, 3, let's take 3, and x 0 dot im show brighter image. Is great. Instead of writing the command in the next line, we can use a semicolon and then write the command after that as well. So here I can write set title is brighter. You don't have to miss the semicolon, or you can write it in another line. Okay. Okay, it's not showing. Let me complete it. Can anyone help me with why other two images are not showing up? Please go through this and let me know that what mistake I am making. I know the mistake, I just want to know that you guys are listening or not. Please let me know what mistake I am making, and that's why the other two plots are not showing up.
Madam, you are overwriting on the same image, I guess. Means
Yes.
AX0 is everywhere.
Yeah, thank you so much. Okay, so I'm writing this everywhere, so that's why it was not visible. Change it. Now as I run this, now you can see this was the original image, and in the darker image, maybe I have written, no, I am overwriting that. First is the brighter one, right side is the original one, and the middle one is the darker image. Okay, so this is how we perform the brightness and the contrast adjustment. Now moving on to the next part. In this particular section, if you have any doubt, please let me know. Like here we have used multiple things like np.clip, and then we are plotting it using the subplots command. Okay, anyways, now moving on to the next part. This is the edge detection and the filtering. Edge detection and filtering. So edge detection, it identifies the sharp intensity changes. Okay, so whenever there is a sharp intensity change, so there is usually an edge, so that's why its name is edge detection. It is important for segmentation. It is important for, like, if we are working with the medical images, it is important for segmenting its boundaries. So for that, edge detection is helpful, and also the filtering. So now let's start. So from this import data, we have already used the data color. Now we will see if it will be used or not. Okay, and filters. Now moving on to the second library, I'm again writing because maybe sometime it throws an error. So again, I'm writing numpy, and also I'm again writing it because if you don't want to run the whole cell, whole notebook, you can directly run it and it will work from this particular cell onwards. Okay. And also you can also run it in any order you want. First of all, you can run this particular cell and then you can move upward as well. And then moving on to the next library, matplotlib.py plot. Let's say, okay, it's working. Now let's take an image of maybe the astronaut this time. Astronaut, and don't forget to put the round bracket, and then let's convert that into the grayscale quickly. It will be, the concept will be recapped. RGB to gray, okay, and the image color dot RGB to gray. Okay, so now let's convert it to the this one. Let me quickly show you the elements. Okay, no, let me start with this. Wait. Okay, so that's why I wanted to show. So here I'm applying a Gaussian blur filter on the gray image too. Okay, this is a 5x5 mask. And now here it is throwing an error that it has no attribute as Gaussian blur. Okay, so what might be the case? Maybe we are missing the gray image part. I'll quickly write that and I'll explain that. Okay. Mhm. Okay, again, there is having some error. I'll move on to the binary thresholding and then we'll discuss edge detection later or tomorrow if the time is there. Otherwise, tomorrow.
Ma'am, I guess Gaussian spelling you have to check. It should be maybe GAUSSI.
Okay, thank you so much. Let's see. No, still not working. Okay, maybe we will resolve it again now. Let's check. We are first using the image and then we are converting that it into the RGB to gray using this command. We'll see if it's running.
Yeah, because the spelling was GAU.
Okay.
Spelling you have typed was GUA. So there that must be the thing. That is GUA. It should be GAU.
Okay, I'm just checking it again. Oh, GA. Yes, it's running. Thank you so much. Okay, so after I have applied this, so here I want to show that if I was running this first and then this and maybe this command just after that, so it's again running. We don't need this because it's already of type qint. Okay, so now let's plot it quickly. Let's see what's happening. BLT dot. Don't forget to write CMAP, otherwise it will again throw an error. And for the next subplot, comma 3, comma 2, dot I am show. So the Gaussian blurring has been performed on this second image. You can see there is some blurring is there on the image on the right hand side. Okay, now let's apply the filters. We have many filters for detecting the edges and other types of things. So we can quickly use the Kenny edge detection filter. Kenny edge is equal to on the blur one, little bit convention. Good. Quickly plot it. For that, now I need that operation which I initially wrote. So as you can see, the edges has been detected of this particular image. So apart from them, we have like there is Kenny, there is Sobel filter, and also there is pre-bit clapation. So based upon that, you can search and you can apply. All these are good in filtering. Okay. So next, moving on to the final part, binary thresholding and mask visualization. So we have performed the thresholding in the previous lecture as well. So again, we will quickly do that. Let's say the threshold we take is 0.5. So how we apply the mask? Let's say mask is equal to the gray image where its value is greater than threshold. Okay, so now we simply have to plot that. Here it is thresholded. What we did was we set a threshold to 0.5 and then we created a mask. We simply considered that full matrix of the pixels, and then the values which are greater than threshold are stored in the mask. And then finally we plotted this. We have visualized that. And now these binary masks, they are very important because they help us to capture the region of interest from the background. Suppose whatever the logic we have applied. So by using this particular logics, maybe anything, any equation or any segmented output or any binary conversion that we have performed, and then we can simply using the threshold value. Here we have fixed the threshold value, but there are but based on other advanced image processing techniques, the threshold values are computed based upon many things like uh, what values of pixels are there in the neighbor of that pixel value, or we can replace that value with the mean, median, these type of things, and then we can create a mask. And then after that, we can apply this mask on the image or on the output which we are expecting, and then we can check further. So now moving on to the pixel intensity analysis. Here we will simply work with the histogram, which is HIST represented using the for the histogram, and the gray and there is bins. How many bins we want the intensity to be shown. And finally, this plt.show. Gray. So for this particular grayscaled image, we here the low intensity values are much more, so that's why at the 0 the peak is there, and then eventually all other pixels are distributed. So this is how we see what intensity is there. So also although we are plotting this pixel intensity at the end of this session, but usually the pixel intensity and using this histogram, it is helpful when we have some image and we first of all view its pixels, and then based upon that we can apply the thresholding, and maybe we have like for this particular thing, if we have to suppose threshold and we have to remove this peak, we can work upon in that way so that we only have this middle section maybe, so that we can remove the brighter or the lighter pixel. So in that way we can proceed. So far we have completed how to load, resize, adjusted the brightness, and since the time is already coming to an end, so tomorrow we will start with the medical image formats, in which we will discuss about the DICOM, Nifty, PNG, JPG image, and then finally move on to the ML and the DL part. So if you have any doubt, you can ask me. I will share these notebooks at the end of today's session. I will share, and you can work upon them. You can work on the Python basics, and you can work upon basic image processing operations which are required for the advanced medical image analysis. If you have any doubt, please let me know. Thank you so much.
Thank you, Dr. Aditi. It was a wonderful session, and you have explained each and everything from the from the starting point, and you have explained everything through the coding and explain the formats and all. And I think it was to the satisfactory to the participants. So thank you very much. On behalf of all the participants, I thank you. So
Thank you
now
so much, sir.
we thank you. So now we end this session and we'll join tomorrow morning. So before that, if anybody want to share anything or want to say anything or want to discuss anything, so we are open to have that, or any networking session or anything they want to share. So regarding material,
Hello,
we will share the material after the completion of the workshop. Yeah, anybody is saying something?
Yeah, Shiksha, actually, one request is there that hands-on session material must be shared just after the session. Actually, due to the lack of network issues, I'm unable to cross-check, once go through each and every step, whatever has been delivered during the hands-on session.
Okay, I will try and I will discuss with Dr. Aditi and will try to share immediately.
Thank you.
Sir,
Okay,
sir, I can share it them if you allow, I can share them right now, or as you can say after this just session ends.
you
I'll
can
discuss
share.
that.
I will share it in the group. You can share me on the WhatsApp, and I will share
Okay,
uh,
sir.
that Google Notebook at the WhatsApp group.
Okay, sir. Okay. Yes, sir.
Okay, thank you, participants.
Thank
It was a very informative session, and we will join tomorrow morning at 9:50. So at sharp 10 o'clock, we will start the session. Thank you. Thank you very much.
Thank you so much, sir. Thank you, everyone.